Hello, hello, hello. Welcome, my friend. How are you? I hope you are well. Asked at the Japanese Mathematics Olympics. Perfect one question. First, you can try to solve the question yourself. Please write the results you found in the comments. Do you think it's worth going to Japan? Or go to Japan? Yes. If we start our question, x to the y minus y to the x is equal to 17. Said that x and y are positive integers. He wants us to find x, y values too. Now a little bit to solve this statement. We need to do magic. What can we do? Let's try to get two square differences. So what do I mean? Let's remember the two square difference. A squared minus b squared is equal to minus b times a plus b. I need to get this statement here. If we give an example, I said 20 to the 4 minus 18 to the 4. For example, I want their strength to be 2. I can write this statement like this. Over 20 squared squared. Minus 18 squared over 8 squared. If you pay attention when you write this statement, look, 2 came here and 2 came here. So I got the difference of 2 frames. Then I say that this expression, I use this feature x above, e divided by 2, square minus e over x over 2. Squared is equal 17 if you pay attention. When we multiply this 2 and 1 to 2 right here, when we multiply x divided by 2 by the question above again, what can I do after that? Let's start applying the two square difference here immediately. Above x, e divided by 2 plus e over x over 2 times x to the y over 2 minus y to the x over 2 is equal to 17. Now after this part, I need to focus on 17. 17 how one number? 17 1 is a prime number? Prime numbers we know. Divisors? 1 and he will be. In this case, if you pay attention to this part, this expression is bigger than one number. The expression here is one smaller number. So I mean, x to the y over 2 plus y to the x over 2 is greater than x over y over 2 minus y over x divided by 2. In this case, what can I say? Now this statement, 17 is this expression is 1. I can say we stated. Now later then, let's write the following immediately. Above x, e over 2 plus I to the x over 2 is equal to 17. X to the y over 2 minus e to the x over 2 is equal to 1. Look, I call it the first equation. And I call it the second equation. Equation 1 and 2. When we add these two equations, if you notice here y to the x over 2, and the expression here is minus. Since y to the x divided by 2, their sum will be 0. So I have 2 x to the y over 2 is equal to 17. When we collected 17 of them, we reached 18 results. Now what can we do next? Both sides immediately. Let's divide the expression we call x to the y divided by 2. What happened? 9. Now look, if you're going to pay attention, there's a 2 here. What do I have to do? I have to get rid of these 2. Let's remember that feature in the numbers just above. What was it? C nth force of a to the b. A to the b times c is equal to. Then if I'm going to apply this here, if square of both sides. I got the square. Be careful. This will take each other away. What will happen? Our expression in this case, x to the y, is equal to 9 squared. The number we call the square of 9 is 81. Now this number 81 is different. Which numbers? Base, and we can write it as a top. Let's focus on it. The expression we call x over y can be 9 squares. Yes, what else could it be? Maybe the fourth force of 3? These are our alternatives. In this case, if you pay attention, the values we call x and y. What happened? 192, what happened? 3 to 4, of course. This was part 1 of the problem. There is another side to this problem. Now we are over x. We found 9 here, which we call y divided by 2. In the first and second equations above, we know that expression is 9. Then it will come to your statement here. What number in 9 makes 17? Of course, 8. So I can say, what should be the expression I call y to the x divided by 2? Should be equal to 8, with the same logic on both sides. What am I doing again? I take the square. When I square, the expression we call y to the x is 8 squared. So 64 will come. Of course, here's 64. How can I get? I'm thinking again. I can write as 2 to 6. I can write as 4 to 3. Look here, I said y and x values. In this case, what happened? 8 to 2. 6 came to 2. 3 came to 4. The most important thing here is in these two tables given to us. We will choose the values that are common to both. Look, if you pay attention with the friend over there, friend partner over there. Then our question, first of xy binaries. What happened, guys? 3, 4. So the question is over here, no? Now there is one more solution to the problem. Let's try to express it. But don't forget to like and follow before. If you have different methods, you can write in the comments, solution of the problem. You can write if you like. You can write if you don't like. Different things we can discuss about math. Please don't forget to like and follow. Now after that, look what our question was in the first place. X to the y minus e to the x is equal. Think of numbers over 17. Now when we think of higher numbers, look, I'm here. Imagine if I took y, for example, 1. I get 1. If I get e1, if I write instead of equating, I saw how many x to the 1 minus 1 to the x expression came. 17, so from which number we subtract 1, it becomes 17. Of course I can hear you, what is it? And 18x if we get 18 here. Look, our question is turned into this. 18 over a minus 1 over 18. What is the 18th force of 1? 1 really. This is our equation that he provided. In this case, my answer is xy 3.4. And also what? 18 to 1. We can say this. Say don't forget to like and follow again. Goodbye, see you, bye.